Hello, my name is Cameron.
Hi, my name is Hakam.
Hi, I'm Daniel Ferrari.
And I'm Huang of Odo. In this video, we'll be going over loss aversion and its effects on sunk costs. First things we need to explain is what a sunk cost and what a loss aversion are. A sunk cost refers to a cost that cannot be recovered. A business expense that should be ignored when it comes to future decisions. Loss aversion is the idea that people would rather avoid a loss than to obtain a gain of an equal amount. An example would be people would rather not lose $100 than to gain $100.
So if a sunk cost is a cost you can't get back, what happens if you keep investing resources because you put in those sunk costs? This is called the sunk cost fallacy. The sunk cost fallacy occurs when an entity continues to invest in something due to the previously invested resources and not wanting to let those resources go to waste. This should be decided based on present value and whether the future benefits are greater than the future costs, and not on the already invested resources. One of the most famous examples of the sunk cost fallacy is the Concorde fallacy.
A more general example would be, say you decided to open some kind of business. To open up this business and run it, you need to get all the necessary equipment, employees, and other resources. These would be considered sunk costs. After some time, as you run the business, you see that you're in the red or running at a loss. Rather than shutting it down, you decide to continue investing more resources into the business, hoping that things will turn around. Even though it may be a better decision to shut the business down entirely. This would be the example of the sunk cost fallacy.
The Concorde was the first supersonic passenger commercial airplane. The project was worked on jointly by aircraft manufacturers in both Great Britain and France. Both the British and French governments funded a large portion of the project. While in development, it became clear to designers and engineers that the development costs of the Concorde were so great that they would never be fully recovered during its lifespan. Nevertheless, at this point, lots of money and time had been put into the project, as well as it gaining a lot of publicity. So the British and French governments continued funding. The Concorde was barely even physically possible, requiring the engineers to come up with many workarounds to get it flying. One example of this is the droop snoot. In order to be stable at the over Mach 2 speeds the designers wanted, they needed to make the nose cone of the Concorde very long. This, however, proved to cause more issues since when a plane is landing it tilts upward, and with the nose cone being so long, the pilots were unable to see the runway. This meant even more money had to be poured into the project, and the engineers developed a complicated system of tilting the nose cone down during the landing process. This was just one of the many design challenges that should have been a red flag to engineers and investors that the Concorde wouldn't be viable and that they were stuck in a sunk cost fallacy.
As we all know, the Concorde was a huge failure economically for all parties that took part in the project. In a well-mannered and organized team, everybody has a say, including the engineers. With loss aversion and sunk cost fallacy, the engineers play the role of soldier, as the economic decision of whether to continue spending resources on a failing project to try and create a success out of it because the resources spent will go to waste, which is the sunk cost fallacy aspect, or to quit the project, forget about the money, and accept all the losses because you don't see the outcome favoring profit, which is loss aversion aspect. These decisions can affect what an engineer does in the workplace. But these decisions can also be affected by the engineers. For example, an engineer can find a solution to a major project and report the solution to the project manager. The decision on whether to continue fixing what is broken and spending more resources to try and create a success is then heavily dependent on the engineer's ability to fix the problem. In the case for the Concorde, many issues arose such as ethical innovation issues, design flaws, stubbornness of management, and alliance ties. These all led to economic and financial issues causing the sunk cost fallacy and force an eventual loss aversion decision. To further understand how engineers are tied up and contribute to the economic decisions relating to the loss aversion and sunk cost fallacy, we can analyze what engineering factors led to what decisions and how they impacted the whole project economically. The race to create a supersonic passenger jet between the English and French and Soviet Union was tense. As the English and French became partners in the project, they took time as the main factor of completion. The team at Airbus had limited time to innovate, design, test, build, and implement the first ever supersonic passenger jet in existence. The engineers at Airbus also encountered many design flaws, such as wing shape and aerodynamics, which would allow supersonic speed, but is unstable at lower speeds, causing landing and takeoff issues. Nose length, which causes the pilots to encounter difficulties while taking off and landing due to the departure and arrival angles. And even ethical engineering issues later on in the life of the project due to design flaws, causing crashes and death. Sticking to loss aversion and sunk cost fallacy, the design failures of the Concorde prior to the global unveiling led the engineering team at Airbus to make the overall design more complicated by finding specific solutions to fix a bad design. This needs resources and money to do, which shows off the sunk cost and fallacy aspect. Money spent to create a bad design and money spent to fix it while continuing to try and find success in it. In the end, the Concorde was released, and it failed with many deadly crashes. An ethical issue arises as the cost of constant failure causing death was too much to pay. And in the end, Airbus was ethically and globally forced to end the project and ground all Concordes, which relates to the loss aversion.
These two examples may seem very different. However, they're made up of the same concept, the sunk cost fallacy. Sunk cost fallacy is the continuation of an investment due to previously invested resources, which has been viewed as a result of the company or the individual's commitment to the investment in order to prevent losing the resources which have already been put into the project. These resources which have been invested are known as sunk costs, which is a cost that is incurred and not able to be recovered. These are treated as a bygone, which a company or an individual would not consider while deciding the future of the investment. These terms both relate to the loss aversion, which describes psychologically why the pain of losing is approximately twice as strong as the pleasure of success. Hence, this helps to describe why the pain of losing a set amount of money is more powerful than the pleasure felt from gaining that same amount. All three of these terms help to explain why the company or the individuals made the decision to keep throwing resources into the project which has no evidence of a future. Overall, it is apparent that sunk costs can be seen in various examples across the economy and in the marketplace, while also relating to engineering in the sense that engineers must also understand this concept and act accordingly to make the best decisions. Sunk cost fallacy has been seen to be the continuation of behavior which is driven by costs that can no longer be recovered. These costs are deemed as sunk costs. Loss aversion is the definition as to why companies and individuals follow the sunk cost fallacy. Finally, the decisions of sunk cost and the terms aligned with it, as well as the ability to identify real-world examples of where these topics are apparent, have been stated.